Hi, this is a video on projectile motion. This time we'll be dealing with an angled launch. So something that's not shot directly horizontally, that's launched at an angle. And I've drawn for you an example on the board, something that's shot at 30 meters per second at an angle of 30 degrees. Right? And let's just say that you're sitting out there in the field with your potato gun, shooting potatoes, boom, and you launch a potato. You want to figure out how far it goes or how long it traveled. If you know where it hit, you can figure out the time that it took. You can figure out the height. There's all sorts of neat things you can do. But let's just start with this example. 30 meters per second in an angle of 30 degrees. Remember, we need to work with components here, vector components, to make this easy to solve. So the first thing that we want to do is figure out what part of that velocity is going in the x direction and what part of the velocity is going in the y direction. That's because forces act differently on the potato in the x direction and the y direction. In the x direction, it has zero acceleration, for example, whereas in the y direction, it has an acceleration downwards of negative 9.8 meters per second squared. And the velocity is not going to be 30 in these cases. It's going to be different than 30. And we can figure it out. This is v sub x, and this is right there, v sub y. So v sub x is just going to be the velocity times the cosine of an angle. So 30 meters per second times cosine 30. All right? Plug it into your calculators. Cosine 30 is just 0.8666 times 30. So that is about 26 meters per second. So v sub x is blue. 26.0 meters per second. V sub y is just going to be v sine of the angle. And if it's not clear to you why it's sine and cosine, take a few minutes, sketch it out, and I think you'll understand why pretty quickly. 30 meters per second times the sine of 30 ends up getting 15 meters per second. So 15 meters per second. Now, you're looking at this and you see two variables in each one, and you need to figure out where it hits and how long. Well, let's think about this for a second. It's hitting at the same elevation that it starts at. So it goes up, but when it hits, its y value is going to still be 0 meters. Because it's hitting at the same elevation. X is not going to be 0, but y is going to be 0. So there you have three variables and two unknowns, but that's all you need is the three variables to solve these two unknowns. So you can, for example, say x equals v naught t plus 1/2 aet squared. You have all that, right? Oh, I made a mistake up here. I realized I made a mistake. That actually should be the initial velocity. I wrote it as the final velocity. Let me change that. 26 meters per second and 15 meters per second. Sorry about that. Okay. So V naught we have, T we don't have, but we could solve for it. X, Y we have, right? So Y we have, V naught we have, T we don't have, 1/2 we know, A we know. So the only variable that we need to solve for is T. But the challenge is that if you're trying to do it with this, you have a T and a T squared. That's where you need to start getting into the quadratic equation. If you said 0 meters Y is equal to V naught 15 meters per second times T plus 1/2 negative 9.8 meters per second squared times T squared. And you don't want to mess with the quadratic equation, so there are easier ways to do it. So there are really a few easy ways. I'm going to show you a shortcut right here. And the easiest shortcut to remember is that if something is launched, and you'll see this in conservation of energy when we get to that, with a certain vertical velocity, when it hits, it's going to hit with the same vertical speed, just in the opposite direction. So this, horizontally, when it's launched at 26, stays at 26 the entire time. This goes up at 15 meters per second. And then it slows down, and at the very top of its trajectory, it stops. The acceleration is still the same, but it stops and then starts accelerating, continues to accelerate, but it speeds up in that negative direction. So when it hits, its velocity is negative 15 meters per second. If it hits at the same elevation. Doesn't always do that, but in this first example it will. So then we can solve this pretty easily. We can say V equals V naught plus AT. So negative 15 meters per second equals 15 meters per second plus your acceleration, negative 9.8 times T. You end up getting T is equal to negative 30 meters per second, because negative 15 minus another 15 is negative 30. And we divide by this, divided by negative 9.8 meters per second squared. The units end up working out to be seconds. That's a good sign. So it should be around 3 seconds, a little bit more than 3 seconds. Put this in my calculator. 3.1 seconds. So we know that it hits 3.1 seconds. Right? So that's when it hits. You want to find the distance at which it hits. Then you just need to use another one of those kinematics equations. You can say distance is equal to basically average velocity times time. So 1/2 of 26 plus 26 meters per second. That's just the average velocity of this. The average of 26 plus 26 is 26 times 3.1 seconds. And you get around, I got 79.6 meters. That was pretty easy, right? Sometimes knowing these little shortcuts helps. Let's say we want to figure out where it is at the maximum height. So this is when it hits right now, right? When it hits. At the maximum height, it's going to be different. Make sure you pause and write these down if you want. Let's see how this changes. At the maximum height, boom, that's like right there. Max height equals basically a half of the trip. Max height, the acceleration is still the same. The elevation is not. We don't know what the elevation is. We do know, though, that the distance is not 79.6. It's actually gone half of that distance. So 39.8. So the distance is half. You might not know all these variables in the problem, but you can figure them out. 39.8. The velocity, still 26. Here, in the y direction, at the very top, actually stopped. 0. And the time, it's just halfway through the trip again. Halfway through the trip is 3.1 seconds divided by 2. So 1.55, so just half of this. About 1.5 seconds. So that's at the maximum height. You want to times your time of 1.5 seconds. So you end up getting 1/2 of 15 times 1.5. Is 11.25 meters. So that's how high it goes at its maximum point. 11.25. And this is not when it hits, by the way. This is at the maximum height. Right now. And you could even pick a different point on it. You could pick any time that you want, and you can solve based on what you know. Because at any given time, any other time, you know that the acceleration is always going to be 9.8. You know the initial velocity, and you know those three variables. And then you can just pick in the time. And once you get the time, you get the third variable for both those sides, and you can solve for the rest. So this is an angled launch. We're also going to see in lab and in class an angled launch that's not at an even elevation. And that gets a little trickier even than this. But let's make it nice and simple. Not so different, really. So let's say that it was launched here, and it hits here at a distance of y is equal to negative 20 meters. Meaning it's basically launched off a cliff. It's the same as everything else, right? You have your initial velocities up there already. You have your acceleration. And now you know that y is equal to negative 20 meters. And you can solve this problem just like you've solved all these other problems. You've got 3 variables and 2 unknowns. Now, the tricky thing to this is if you want to solve time, you can either use a quadratic equation, or the better bet is to solve for the velocity first, v sub y first. And this is what you're going to find works best. So you can say velocity is equal to, what do we know? We know initial velocity, we know acceleration, but we don't know time, so we need one that doesn't have time, this one right here. So v squared will v naught squared plus 2ay. And when you solve this, you end up getting velocity is the square root of, let's see, 15 meters per second squared plus 2 times negative 9.8 times negative 20. And you put that into your calculator. 15 squared plus 2 times. So that's the square root of 617. Assuming I did the math correctly. Or 24.8 meters per second. So your velocity is now, when it hits, 24.8 meters per second. You know your velocity. Now, knowing the velocity is really easy to find time. So time might just be, let's see, final velocity, v naught plus at. So you get 24.8. Now there's a problem here that when you took the square root of this, keep in mind it can be positive or negative, but we look at it, it's hitting, it's got to be hitting in the negative direction. So that velocity's got to be negative. So negative 24.8 equals 15 plus your acceleration of negative 9.8 times time. So you end up getting time is equal to 24.8 plus 15 divided by 9.8. I divided the negative signs out of there. And that equals 4.06 seconds. And if you put 4.06 seconds, then you can figure out that x distance pretty easily. There are lots of variations on this, but they basically all boil down to figuring out what you know, what you don't know, using these kinematics equations and understanding the motion of objects in 2 dimensions. We'll get more practice on this in class, definitely. But for now, this is the end of the projectile motions video. Thank you.